Okay, we're going to make a second part to this video since our first one got cut off and I didn't want to start all over. So we'll just start with number 5 here. We're going to talk about using these special right triangles now to find the value of the variables. So if we go back to chapter 3, we already talked about special triangles, so let's fill this in. This side is 15. It's a 30, 60, 90 triangle. This is the short leg. So the long leg is going to be 30, or twice the length of the short leg. And the long leg, sorry I said long leg, but I meant hypotenuse, is going to be twice the length of the short leg. Then the remaining leg here is the long leg, and it is going to be the short leg times the square root of 3. So 15 square root of 3. On number 6, I have a 30, 60, 90. And we have to look closely because this is kind of tricky, where it says 30 is up here, which is opposite the shortest leg. The triangle is not drawn to scale, obviously, because this is not the shortest leg. But we're going to go with what the notes say. So this is opposite the 30-degree angle, would be 6. And this would be 6 square root of 3. And on number 7, it's a 45, 45, 90. So if this side is 6, then this side is also 6. And this side is 6 square root of 2. And on number 8, if my hypotenuse is 10, I know this is a 45, 45, 90 because my side lengths are congruent. So I could take 10 and I need to divide it by the square root of 2. I rationalize my denominator and I get 10 square root of 2 over 2, and that simplifies to 5 square root of 2. So now let's figure out what this has to do with our trig ratios. Let's first figure out what the sine of A. Since it says A, I know this is my reference angle from right here, and circle it. We can say opposite over hypotenuse, since that is the sine ratio, which would be 15 divided by 30. And that reduces to 1/2. The cosine of A is going to be the adjacent side over the hypotenuse, so that would be 15 square root of 3 over 30. And this reduces to square root of 3 over 2 when I simplify it. Okay, the sine of B, let's circle B because it's my reference angle, is the opposite side over the hypotenuse, and that reduces down to 1/2. The cosine of B is going to be the adjacent side over the hypotenuse, so that would be 6 square root of 3 over 12, and that reduces to square root of 3 over 2. Now before we move on, I want you to notice on 5 and 6 that the ratios were equal. We used 30 as the reference angle here, and we used 30 as the reference angle here. And the sine of both of them was 1/2, and the cosine of both of them was square root of 3 over 2. I just want to draw you the most basic 30, 60, 90 triangle here. Once again, not drawn to scale, but this side would be 1, this would be 2, and this would be square root of 3. So if I were to take the sine of 30, I would have opposite over hypotenuse, and it would be 1/2. If I were to take the cosine of 30, I would have adjacent over hypotenuse, and that would be square root of 3 over 2. Just as we found up here. Sorry, I realized I wasn't showing you what I was doing. Let you catch up now to what I was saying. So every time on a 30, 60, 90 triangle, if I take the sine of the 30-degree angle, it's always going to be 1/2. It's always going to be a 1:2 ratio. The short leg is going to be 1/2 the size of the hypotenuse when I do opposite over hypotenuse. Okay, and the cosine will always be square root of 3 over 2 of the 30 when I take the cosine of the 30-degree angle. Okay, let's look at number 7. I'm going to cover up this portion for just a minute. The cosine of A, so A is my reference angle, and I have the adjacent over hypotenuse, so it would be 6 over 6 square root of 2, and that reduces to 1 over square root of 2. If I rationalize my denominator, just to kind of save space here, that would be when I multiply by the square root of 2 over the square root of 2. So this would simplify to square root of 2 over 2. The tangent is going to be opposite over adjacent, so that is 6 over 6, which reduces to 1. Now on this one, cosine of r, so r is my reference angle. I have adjacent over hypotenuse, so I'm going to go 5 square root of 2 over 10. If I'm going kind of fast, you can pause the video every once in a while and double check. But this is my adjacent side, this is my hypotenuse, and I get the square root of 2 over 2 when I simplify that. The tangent of r would be opposite side over adjacent side, and that reduces to 1. So I found the same thing. The tangent of the 45-degree angle was always 1, and the cosine was square root of 2 over 2. If I draw a 45, 45, 90-degree triangle in the most basic, simplest terms, I would call this side 1, this side 1, and this side square root of 2. If I take the tangent of one of the 45-degree angles, now it doesn't matter which one I choose, but if I take the tangent, I would put opposite side over adjacent. It's always going to be a 1-to-1 ratio because they're always going to be equal. That's why the tangent is 1. If I were to take the cosine, I would take the adjacent over the hypotenuse, which would be it would be 1 over the square root of 2, which simplifies to square root of 2 over 2. So the cosine of 45-degree angles is always going to be square root of 2 over 2. The tangent is always going to be 1. That will always be true. So when you need to find the trig ratios of special angles include a 30, a 45, or a 60, then you can find it by drawing the triangle first, like this. You need to memorize these two triangles right here. This is a simple 30, 60, 90 in the most simplest terms, and this is a 45, 45, 90 in the smallest terms. So be good to memorize those when you need to draw the triangles to find the trig ratios. If the reference angle is not special, then we use a calculator to solve it. And I'm going to attempt to just put my calculator down here and hope you can see the screen. Maybe see also what I'm writing. If I zoom out a little bit. There. Straighten out. Okay, so if I need to find the sine of 15, that's what the first problem says here. I'm just going to use my calculator, and I'm going to push sine of 15 and enter. And I get 0.2588. I think the instructions say 3 decimal places, so round it to 3 decimal places. And we would just write that right here. The tangent of 25, I just push tangent 25, and I get 0.663. The next one says the cotangent of 40. One of the easiest ways to do this, because there's not a cotangent button here. And you see these ones above that say sine inverse, cosine inverse, tangent inverse. We don't want to use those yet. We haven't learned what those are for. So that's something different. But cotangent is the inverse of tangent. So I'm going to find the tangent first. I'm going to say tangent of 40 degrees. And I get that number. If I just push this little inverse button, x to the negative 1, it'll take the answer and find the inverse. And so the inverse would be 1.192 to 3 decimal places. The last one says cosecant. So let's remember that the inverse of the cosecant is sine. So if I take sine of 55 and push enter, and then I just use this little inverse button right here, x to the negative 1, push enter, and I get 1.22. That's it for 8.1 Day 1 notes.